Hello, everyone, and welcome to the CMA webinar series. I'm Mike Wilkening, part of the content team here at ARC, and I will be your host for today's webinar, Stated Behavior versus Actual Behavior, How AI Can Bridge the Gap, hosted by our friends at Hivery. And let me tell you, if you have an interest in AI or even just a curiosity on why people say one thing and do another, you're going to love this session. We're going to take a deeper dive into the disparity between stated and actual shopper behavior in retail, and we're going to take a closer look at how AI can accurately bridge this gap, leading to data-driven strategies that enhance shopper experiences and decision-making processes. Now, we invite your questions throughout today's webinar, so feel free to enter those in the chat function on your screen, and we'll make sure to get to those throughout the session, and particularly toward the end. It's now my pleasure to bring on today's speakers from Hivery. Heather Martin, the Vice President of Marketing and Sales, and Kyle McKenzie, Vice President of Engineering. Heather has a background in big data analytics and shopper and category insights and has a track record of delivering those difference-making granular insights to drive actions for clients. Kyle, meanwhile, is a seasoned leader and mentor in engineering, with experience managing complex technology initiatives and experience in fintech, cybersecurity, the Internet of Things, machine learning, and e-commerce. With that, I'll hand it off to Heather and Kyle to kick off today's webinar. Heather, Kyle, welcome, and the floor is yours.
Thanks so much, Mike, and thanks to CMA for having us here today. For those of you who we haven't had a chance to meet yet, Hivery was founded out of the Coca-Cola Founders Program in partnership with Australia's leading data science organization, CSIRO's Stady61 Labs. We were founded to help retailers and CPGs make better decisions, and specifically assortment decisions. The team has experience across the leading data providers to our industry, as well as CPGs and leading CPGs and we're doing jobs that you guys are doing here today. But we're not really here to talk about that. We're here to talk about this, the fact that the most important thing in retail is to make sure that the right product is in the right place at the right time. And I'm not telling you guys anything you don't already know. All of our companies were really built and exist to try to make sure that our products are available to shoppers when those shoppers need them. The webinar today will have 3 different parts. I'm going to kick us off by talking about some of the challenges to getting the right product in the right place at the right time, those challenges that you guys are living every day. We're going to pass it over to Kyle to transition to how we can think differently about behavioral data. And then I'll close us out with a couple of examples of how we've seen this done in real life. So let's talk a little bit about the complexity in our world that impacts the ability to make effective shelf assortment decisions. The first one is there are a ton of variables that we have to work with that can impact and correlate to assortment decisions and the actions that shoppers take on the shelf. The second is that there are gaps in traditional market research, like the stated behavior versus actual behavior gap that Mike kicked us off with here today. And the third is that there are limited resources because money does not grow on trees and humans need to sleep. And I'm going to dive into each of these just a little bit more. The first one is that there are billions of variables that impact behavior. I was doing a little bit of research on this, and there's a company out there who says that in order to get to actionable personas, you have to add together demographics and psychographics and then multiply that by buyer behavior or category behavior in order to get there. And that math equation just adds to how many variables there are out there. So we have, traditional demographics, ethnicity, age, income, marital status. Then you get to layer on things like, well, what are their shopping habits? What channels do they shop? Are they heavy category shoppers or light category shoppers, as well as life events? Are they a new parent? Do they have a new pet? Location and regionality. And then there's a whole bunch more that are starting to come into play and have been coming into play over the last couple of years. Lifestyle, opinions and beliefs, stances on sustainability, political views. We're seeing that impact brand decisions at shelf. And so there are so many variables out there that impact behavior. And in order to really make a view of who our brand or our category shoppers are, you have to take an average of averages approach, because how could you possibly look at all of these and take them into account? And then analyzing this to get to the truth is even harder. When you're doing surveys or primary research, you have this impact of recency bias, where if you ask them what goes on with your purchases in the entire category, they're going to focus on their most recent purchase. This concept of omission bias in panels, where items of sin or items that I just don't want anyone to know that I purchased are unreported altogether. And then the prevalent say-do gap, right? Where yes, I will tell you that I want to be more sustainable and I want to make sustainable choices at shelf, but if you're living paycheck to paycheck and I'm standing at the shelf trying to make a decision, what I really need to do is feed my family, right? And so there are tons of consulting organizations out there, approaches to try to figure out how do I make sure that the data that I'm getting isn't biased and is actually true and accurate. And then the third is there are finite resources. There are actual hard constraints that keep us from doing what we need to do. I talk to CPGs all the time who say, man, I have an embarrassing little amount of research on this topic or this strategy that I'm looking to execute at shelf, because money doesn't grow on trees, and the research that we've had to do on this has had to happen at the channel level or at the category level, or maybe I'm working with a category that isn't as high of a priority for my organization, and so I just haven't had a chance to do that. And then there's brain power, right? The billions of variables we just talked about and adding on the biases that exist there. It requires a ton of brain power and specialized people and tools to get at that real answer. And even if I could solve the two of those, time is such a finite resource. There's only so much time in a year. And as much as we all love our jobs, there are other things that we like to do too, like sleep and spend time with our families. And so all of these pieces, the finite resources and the different variables we have to work with, the say-do gap, say-do behavior, actual behavior, all of that makes this more complex. And as a result, the companies that I talk to find that they're kind of stuck in this doom loop of having too much data and too little action. I was on the phone this week with a CPG company working with one of their key retailers, and they said, I asked them, my background is in panel data, and so I asked them, do you have access to panel data? Because it might have helped with the question that we were asking. And they said, well, of course I do, but besides leakage trees, that panel data doesn't really end up impacting the shelf. It's great for building stories, but it's hard to take action on, right? And even when I'm looking at that leakage data, identifying that an item or that a shopper is leaking to go buy another item somewhere else, that's easy to identify. But then what do I do with that? How do I understand where I should put that item and what I should do? And so I'm going to kind of walk you through this, and you all probably know better than I do even what I'm talking about here. So you kind of start with this primary research in order to uncover and explore consumer unmet needs. And this is done at a small sample size level to make sure that we can get as much information as we can without spending too much money on it. And obviously all the biases that we talked about earlier are included there. And then we take it a level deeper and we start looking at panel data, desk research, syndicated data to really understand at a granular level, what does this mean for my business and what does it mean for the shopper? And then you find out that, well, that data is great, but then I have to find a way to actually work with it. And in order to work with it, I have to bring it up to an aggregated level. I have to aggregate it by channel or by retailer or by category or by one of those demographics or psychographics that we talked about, or only things that are over a 130 or 120 index. And then as a result of that, it doesn't really get implemented. We waste a bunch of data, and perhaps that consumer's needs still remain unmet because it wasn't able to be executed at the shelf. And so most of our customers are telling us, it's not that I don't have enough data, it's that I really need a better way to get what I need to get out of it. And so the question I'm posing today is, well, is traditional shopper behavior the best way? The fact is that there are many companies out there that know more about me from the way I interact with their websites and their products than if they sat down and had a conversation with me and I answered all their questions with all of the biases that are inherent to who I am and what I do. In social media and Facebook and Instagram, they're looking at things like scroll speed and identifying, well, when does she slow down? What colors of the items are there when she slows down? What ads does she hover over but maybe not click on? Amazon not only recommends the next best item that I should be purchasing as a result of my purchase behavior, but actually what size I should buy. And they've never asked me my height and weight. And then Netflix, I think everyone knows, they're looking at profiles of consumption behavior. So what movies am I watching? What shows am I watching? Do I watch them all the way through? Do I watch multiple seasons? Do I stop in the middle? Do I stop 10 minutes in? And they're using that and profiling me against all the other like households and identifying, well, what could I recommend to her next? Because I want to make sure she stays in my app as much as possible. And the fact is that not only is this kind of describing my behavior, but it's doing something more important, which is it's informing future purchase decisions. And I will tell you that on all three of these, those ads on social media, those recommendations on Amazon, and those what next to watch on Netflix, those all impact my future purchase behaviors within their sites. So I'm going to tell you a story, and I have a 4-year-old. So we do a lot of bedtime stories. So I'm going to start this one with Once Upon a Time. There were 2 entrepreneurs who were part of the Coca-Cola Founders Program. And the goal of that program was to give these folks a big business question and give them access to Coke's resources to go out and solve it. And the big business question they were given was increase sales and decrease labor across all of my vending machines. And so they looked across Coke's resources and they found that, you know what, there is no shopper panel for vending machines. There is some research on immediate consumption and immediate consumption channels like convenience or, you know, front-end coolers at large format. But I think we can all agree that the consumption occasions between vending and those are quite a bit different. And then they looked across and they found that traditionally a vending machine was assorted based on the building that it was in. So a train station has all the same vending machines and a hospital has all the same vending machines. And I think we could all agree that the consumption occasion in the operating room staff lounge and the operating room waiting lounge with the families, those consumption occasions are very, very different. The mindsets are different, the feelings are different. And so they ran a hackathon and they asked that hackathon the same question that I'm going to ask Kyle here at the end of this Once Upon a Time story. And that question was, what I do have is point of sale data. And how could I take that point of sale data and uncover that shopper behavior data? How could I uncover those consumption occasions to then predict how items would perform? And how can I use that to answer this big question of how do I grow sales and decrease labor across my fleet of vending machines? And so that's the question that you and I are going to ask Kyle here today. Over to you, Kyle.
Thank you. It's a great question. And what we're really asking when we ask that question is, are we able to learn from data? And learning from data is tightly linked to the thought of what we would consider to be AI. Today, there's a ton of hype about AI and the advancements in AI, but it's actually not a really new or modern concept. AI was actually invented way, way back in 1956 at Dartmouth College by John McCarthy. And it's undergone many periods of spring, and we're in an AI spring right now with tons of advancement, enthusiasm, massive investment, and tons of technological discovery. These periods are traditionally followed by a period of overpromising, a sharp decline in investment, and then a period of AI winter where only fringe research groups continue. And this has been going on since 1956 until today. The big difference about the period we're in right now is that our period is incredibly long. We're over 10 years into an AI spring and we're continuing to see rapid advancement. The second is the rate of technological advancement. We're going to talk about a few of these technological advances now. So in 2012, in an annual image computer vision competition called ImageNet, we saw AlexNet. And AlexNet was a pioneering model that brought in revolutionary techniques in a subspecialty of AI known as deep learning. 2 years later, in 2014, we saw GoogleNet. And GoogleNet introduced the Inception architecture for machine learning models. The very next year, we saw ResNet. And ResNet introduced deep residual neural networks building on deep learning of 3 years before. Most notably, in 2020, we saw GPT-3. And GPT-3 introduced the world to a state-of-the-art language model. And that, of course, is the predecessor to the now ubiquitous ChatGPT. We'll move to the next slide. So the rate of advance has many people speculating about the time when AI becomes more intelligent than humans. Really, that's the time when AI can learn anything from data. The field's most bullish advocate, Ray Kurzweil, has predicted that machine intelligence will surpass human intelligence by 2045. But most experts agree the time frame for that is at least several decades further away. And this means that the concept of general AI, which is AI that can learn of its own accord and learn anything, is far off in the future. Though a small number of companies like Google DeepMind or OpenAI are pursuing that vision. What this leads to in the current time is a preference for specialized or narrow AI. And specialized or narrow AI are applications like email spam filters, facial recognition, content recommendations or product recommendations, and even learning from the sensor data on things like self-driving cars. There's this concept in the field of AI that says the easy things are hard and the hard things are easy. Back in the 1950s, we thought we were going to have computers that were going to have all of the human senses except for smell. As it turns out, it took us another 60 years to get computer vision to be something that was feasible, but we were able to create chess champions out of computers in the 1970s. In a field like category management with a wealth of domain knowledge, complex business rules and relationships, we're going to find that specialized and narrow AI models are going to provide much more value, at least for the next few decades. We'll go to the next slide. We're going to talk now about AI application. At a practical level, we're going to talk about how at Hivory we used machine learning techniques like deep learning to predict demand transfer. So we're going to start with an example, and we're going to show you where we're trying to get to. On the top, we have store A, and on the bottom, we have store B. Within those stores, we have two segments. We've got a tablet segment and a liquid detergent segment. And the question we want to know is how demand will transfer across the products, including a walkaway score where no product is purchased, which is denoted by the blue X, when we remove product 2 and product 4 in store A and product 4 in store B. We also want to know the impact on incremental sales for both stores. We'll go to the next slide. The first piece of magic here is ensemble learning. One model by itself is unlikely to be able to give us a useful prediction, but we can couple together multiple models in a layered fashion to create a more complex architecture for machine learning that allows us to learn multiple patterns and put those insights together. In this case, we start out by doing something that's known as clustering in machine learning. Clustering is really quite simply finding groups of related data. So if we look at the diagram on the left, we start out with unclustered data, everything is blue. We might see that there are some groups of data where the dots appear closer together, and the algorithm produces the output on the right, where we see the algorithm has found a green region, a red region, and a blue region, and consider those to be 3 distinct clusters. In our demand transfer, we use a clustering algorithm to learn which product groups belong together, and a neural network which learns how the demand will be transferred across the groups. The neural network is optimized by minimizing a loss function. In our case, the loss is mean absolute error of the model. And we minimize this error with a process known as stochastic gradient descent. We'll go to the next slide. So our model approach is to learn 4 different things. We learn product groups, we learn store mixtures, and then we learn to predict product scores and demand transfer results. So we use a clustering machine learning model, just like we saw earlier, to learn product groups that compete for sales. So these might be called latent shopper segments, like the budget single can drinkers or the budget pack beer drinkers. For each product in a product group, we're going to generate a product score based on popularity and shopper preferences, and then convert the score into a probability. During the same time, we're also identifying store mixtures of product groups to optimize store assortments and maximize revenue. An example might be budget pack size drinkers. And lastly, we use the product groups, product stores, and store mixtures to predict demand transfer, including the walkaway score. Now, this probably sounds like a fairly reasonable and maybe a slightly complex approach. And honestly, when we first thought of it, we thought we were pretty clever. What we actually learned was we weren't learning demand transfer. what we were learning was correlation between products and product groups, which was an interesting problem, but not really all that valuable to any of you. The solution here was we needed more data and we needed different data. So we needed to augment our behavioral data. This led us to go and use something that was not terribly common, and we asked to use the consumer decision tree. So these little used pieces of information ended up providing the missing detail of consumer behavior to the model and allowing us to get very accurate demand transfer predictions. We'll go to the next slide. So on the output, we found ourselves able to find out what would happen if we remove 2 products from a store across multiple segments, find out the incremental impact on the sales, and we were able to see the walkaway score and how it changed as we remove products with demand transfer. All right, that's all from me. Heather will tell you more about other insights we found with data.
Thanks, Kyle. So what does this look like in real life? So when I was talking through the different types of psychographics and demographics and also store attributes, one of the things I mentioned was competitive stores, right? So in my career, people are always asking, well, if there's a competitive store within a couple of miles or in the same parking lot, how should that impact my assortment and how does that impact my shopper? And so in this particular scenario, we were testing out the demand transfer model that Kyle was just talking you through. So this is several years ago. And one of our co-founders, a PhD in machine learning, was looking at the data. And in general, what we found is that when we removed Coors Light in these particular stores, the demand transferred generally where we would expect, right, to other light beers and things like that. But there was one store in Arkansas that showed a significant rise in King Cobra sales when we removed Coors Light, which was odd because King Cobra is a full strength beer. It's not fairly common. I drink a lot of beer. I've never heard of it before. And he thought, well, maybe this is a bug. Maybe it's something we need to look into. And so he shared it with our client. And the feedback was, well, that's really cool, actually, because there is a convenience store, a gas station in the same parking lot as this store. And they have been promoting King Cobra over time. Now, we had not taken in any of the data from that gas station. But what we were able to find is that the algorithm was able to accurately capture the unique demand of these workers who had developed a preference for this beer and for getting the most bang for their buck as a result of the promotion that was in that same store. So that one was really interesting to us. The second one is one that we've seen across many, many categories that we've worked in. And I imagine that some of you are seeing the same thing, which is we're seeing this bifurcation effect, right? This concept that as a result of maybe leftover COVID impacts where people learned how to indulge at home and inflation, which are driving people to spend less, we're seeing this bifurcation in the category where higher income shoppers are trading up, reflecting a shift from outside occasions, bringing those to at-home indulgences, whether that's in beauty or in food or for specific eating occasions. Whereas lower income shoppers being squeezed by inflation and having only so much money to spend at the grocery store are actually trading down to save money. And so what we're seeing is this shift to both ends of the spectrum within a category, with these folks trading up and trading down. And without taking in any demographic information or any income information, just analyzing the store level data, our technology was able to detect and then recommend, based on those subtle market trends, the increase in higher end items and the increase in lower end items, while kind of shifting away from that middle ground. So again, a situation where behavioral data was uncovered and then assortment recommendations were made as a result of just analyzing the data that we have at our fingertips. And this third example is near and dear to my heart. We were working in a sauces category, and as you guys can probably imagine, sauces have very, very regional impacts. So I've spent a lot of time in Texas. I lived in Austin, I lived in Dallas, and my brother lives in South Carolina. And I will tell you what, I cannot get on board with that mustard-based barbecue sauce that's out in South Carolina. And certainly, I know he feels the same way about what we have over in Texas. So as a result, this category tends to have very regional differences, and a lot of times merchants and category folks think, you know what, those are hard requirements because we need to make sure that the sauces that are regional are staying in those regions. But on a hunch, we said, I wonder what AI would do if we looked at this and removed those regional constraints and we just let it kind of rip and say where it thinks those items should go. And what it found was actually there's this beloved fast food restaurant in Texas, and they have a sauce that was on the shelf. And the AI, when we ran it unconstrained, recommended that that sauce be distributed up in Chicago and in Colorado and a little bit along the way. And when we looked at that and then we did some Googling, what we found is that the post-COVID migratory patterns of Texans were bringing those Texans to Colorado. That's where I live now, so I can vouch for that, as well as Chicago. And so again, without taking into account any of those lifestyle changes or moving or asking someone if they've changed their address in a period of time, or even knowing who are Texans and who are not Texans, the AI was able to uncover those trends and really see that. So what are we saying? Are we saying that you should just throw out everything you've been doing and just use your store level data and AI? Absolutely not. That's not the case at all. In fact, in Kyle's section, you heard that there's an opportunity to leverage behavioral data and traditional methods to influence what's happening with the AI and what's happening at the shelf. But I think what I am saying is that the best behavior, the best predictor of future behavior is past behavior, right? The best predictor of future purchases are past purchases, and those past purchases are in the store level data that y'all have access to. And so I think as we think through how do we make better decisions in assortment, and especially in a world where the number of variables, the number of psychographics, demographics, aspirations that come into the analysis that we're doing around our categories and around where our brand should go in the future. As we think through all of that, we need to find a way to augment what we're able to do as humans, what we're able to do with those finite resources of money, time, and brain power that we have. And how do we make sure that we're making the best decisions using all of the available data that we have in order to do that? And so my position, and I'll be bold to state this here today, is that if you can uncover behavioral data through those latent segments that Kyle was talking about in store level data and get more actionability out of that data, then we can use things like panel data and survey data and primary research to layer on to help build out those stories and help us understand the trends that we're seeing and that AI is helping us uncover. That is the end of our prepared slides section. I've got maybe one or two questions, and certainly we have time for more. If anyone has any additional questions, they can feel free to throw them in the chat. So the first one that I have here is around where we see the future of AI going, and especially in regards to retail and helping to augment decision making, and what we really kind of see from a future looking perspective. And so Kyle, maybe I'll let you start that from a technology and an AI perspective, and then I can kind of layer on from there.
I think what we're starting to see, and even in the last year, we've started to see more of this, we're making use of existing data that we didn't think was high value. So security cameras are starting to be utilized as additional input so that we can use modern image processing techniques to find out features of human behavior. Even if we're not identifying humans on the floor, we're starting to see how they're interacting with the fixtures, with the products on the shelves, how much time they're spending, where your hot zones are in your store and where the cold zones are. We're going to continue to see that sort of evolution of data. In certain regulatory markets, you're going to start to see things like RFIDs being used, and those will give you even more data. As you start to look at integrated supply chains, we're going to have more and more data about individual shoppers, and those are going to give us more precise ways to use demographics down to the store level. Inevitably, we're going to get closer and closer to closing a feedback loop and having better information about which shoppers are purchasing what in a store. And this is going to impact the ability to make more effective, precise decisions about when you're going to do things with your relays, whether it's a full reset or it's just adjusting end caps. As we move forward in the future and things like AR start to become bigger pieces, then there are more opportunities for even more advanced analytics, because at that point you have incredibly pinpoint accurate persona data about each shopper. And that's really the point of perfect personalized information for each shopper in the store.
I actually don't think I have anything to add to that, Kyle. So thank you very much. The next question we have is around how AI can augment and help with assortment processes in portfolio assortment and category management resets. And as I think about this question, you know, across the folks that I've talked to, one of the things that comes up a lot, and I'll maybe highlight two. The first one is, am I resetting the shelf when I should be resetting the shelf? As frequently as I should, or maybe less frequently, right? Depending on the store, the category, the retailer, et cetera. And so what we're seeing is we're starting to see retailers and companies look at, okay, well, can you tell me what the opportunity is if I were to reset it 4 times a year, 2 times a year, only 1 time a year? And maybe I start making decisions about which categories and which stores I reset more or less frequently, right? So for example, if I ran an opportunity to say, okay, across all of my categories, which ones is it the highest priority for me to reset right now because maybe the trends have changed drastically, or maybe there are new items coming out. What does that look like? And how do I very, very quickly, like within a week, identify across my categories where is my highest value, and then focus on those and move forward with those, as opposed to moving forward with everything on a set schedule, for example. And the other one is around things like clustering. So when I look at the total opportunity, right? We do a lot of analyses because we're doing all of this from the bottoms up. We'll do analyses where we say, okay, let the AI identify what's the total opportunity if I were to assort my category at the store level. But then let's look at, okay, well, what if I didn't do it at the store level because I can't? And so should I do it across like micro clusters? Should I look at, 500 clusters? Should I look at 100 clusters? Should I then look at 10 and 5 and say, what is the opportunity based on that? And what's the upside to increasing or decreasing my labor? And sometimes we find that, you know what, yes, you can get a little bit more out of a store level assortment, but is the juice really worth the squeeze? And should we perhaps instead look at doing something that is more operationally efficient and really understand that within the context of how much is it worth to my category, how much is it worth to my retailer? All right, I think that covers off our questions. So I just want to say thank you again to Mike for having us here. I've thrown up a slide with our contact information in case you have any follow-up questions. You're welcome to reach out to us directly. And also there are a couple of resources, including a guest blog that I did alongside CMA. So thanks so much for that on our website at highbury.com/resources. If we don't have a chance to talk to you after this webinar, I hope we'll see you at the CMA conference here in February. Mike, I will pass it back to you.
Thank you, Heather. Thank you, Kyle. That was wonderful. I really liked some of the examples cited. The one about the sauces was really interesting, and sort of how that data comes into play. And I thought the King Cobra one was really interesting too. Just kind of brings to light how some things that aren't quite obvious at first can become real interesting insights with a little bit of digging and looking in some places that you might not have known to look. So really interesting stuff. Thank you so much for your time today. Thank you to all that attended. And again, we look forward to seeing you at future webinars. Thanks to all and have a great day.